Welcome to a tutorial video on Lua. In this video I'm going to cover objects and looping. In the previous video we talked about a table being either a sequence of data, in which case its entries could be accessed by its index, remembering that Lua starts with 1. In the previous video we saw if we used 1 we could get the first entry within a sequence of data. We could also use tables within Lua as associative arrays or object literal or maps depending on your programming background. That is, we can use key value pairs by setting them up ahead of time by using the name in a string defined in square brackets to access other values. We saw in the previous video that we could use square brackets as part of a key to access integer values. We saw Dan equals 33 and Jordan equals 35. And those could be accessed using the same way that we saw a sequence of data, using square brackets. Instead of using the index of the data within the sequence, we could use the keys in the same way to access the same data. Well, moving on from that idea, we can start to think of objects within Lua as tables. That is, we can see here on lines 1 through 4 that person, a variable, is equal to a table where name equals Sam and ID equals 1, 2, 3, 4. Instead of using square brackets as key value pairs, we can start to think of these as objects that have properties or attributes. We can see here then on lines 6 and 7, we can ask for person.name to get the name of person and person.id to get the ID of person. And it starts to get us thinking through a paradigm where we start to solve problems or think of complex tasks as a series of objects. We can approach that same object-oriented programming model in Lua by thinking along the same structure. So we can define properties and attributes as parts of objects by defining them within their own table, like we did here, lines 1 through 4. So we see person.name and person.id. And let's run this so we see those. So we see Sam, and we see 1, 2, 3, 4, which is just what we expect to see. Well, this is useful if we want to write out the object every single time, but that could get very tiresome. So a way then to create objects is to think about them as tables within tables, or metatables. And that's the functionality we're going to use to create dynamic objects within Lua. Moving down here within the code, we see line 9, human equals, and an opening and closing curly brackets, or we know this as an empty table. We also see we're defining a function as part of that object. Function colon new with the parameters, as we discussed in the previous video on functions, name, comma, ID. So within this function, as we pass the first and second data into it as parameters, it will be equal to name and equal to ID. We see again, as a review of the previous video on functions, the function keyword, its name, and end, and everything else is shifted in at least one space or tabbed within that function to define it as part of that, remembering that Lua cares about how we use white space. So we see we can add on, similar to person.name, a function that's part of that object. However, when we deal with functions that are part of objects, we use a colon. So we see here, we can ask for attributes or properties, name and ID as part of person, using the dot notation. That's very similar across multiple programming languages. We can ask for person.name and person.id. When we're dealing with functions and defining them, we want to use the colon. So we see here, human colon new. So we're defining a function new to be part of the object human. Within this, we're using something new. We're using local. Local is a keyword that overrides any global defined variable of the same name. The reason why this is important is it allows us to define variables outside a function and then use the same name of that variable inside a function by telling it that we want to use a local version. So local self is equal to a special function within Lua called setMetaTable. SetMetaTable sets the table type, sort of a table. In this case, what this is doing is saying, okay, within this, self is equal to a new table, where the type of table that it is, the meta of it, is human, which allows us to then create new objects that have the type human. That is, it allows us to create new objects that are humans. So we see here, set meta table is equal to an empty table with the type human, which already exists as an empty table. So when we run this function, the first thing that we're doing is creating a local variable within this function called self equal to set meta table, an empty table with the type human. Then, within its properties, self.name is equal to name, self.id is equal to id. Remembering that the name and id are what we're passing into this. So we're setting properties on this object that we've defined as an empty table of the type human up here. Then we're returning self, which is a table with the new properties name and id, similar to what we saw up here. But in this case, though, we're creating a new table dynamically and then returning that when someone calls human new. This allows us to create new objects similar to person, but which are now dynamically created when we call the function human new. New is a function as part of human. This allows us to dynamically create objects instead of needing to define them like we did with person. So we see an example of that right here. Dan equals new colon human, or human colon new, with the variable Dan and 1985. If we run this, we see Dan. Print line 19, calling the print function of dan.name. So this allows us to create new functions that are objects that are tables, which is a little confusing, but uses set meta table to create new tables of the type of a pre-existing object. So we see that we can create new humans, human colon new, and defining what their name and ID are. So we can create dynamic objects in Lua. Moving over to looping. In looping, there are many different things we can do. The most common case is the for loop pattern, and we see this across many different programming languages. In Lua, it is for do end, similar to the if then end when we did conditional statements. So we see here, like many other programming languages, the initial case, I equals 0, the uppercase, how far we want it to go. So we can say from 0 to 10, the do keyword, similar to if, then, end in conditional statements, and then we want what we want to happen. And in fact, we see that when I last ran this. This is loop 0 through this is loop 10. So Lua provides a shortcut in a way. When we know we want to run from a certain thing up to a certain thing, we don't have to write something is less than something else. We just say I equals whatever we want, the next value of the upper limit, and do. So knowing that we often run loops from the lowest number to a high number, Lua allows us to shortcut that, defining our initial statement, I equals 0, our upper limit, and do. So from 0 to 10 and 0 to 10 is what we saw when we ran this right here. And for do end follows the same pattern of function end, follows the same pattern of if then end. We've seen multiple times now. We can also move through an array using a function I_pairs. So we see here for I, similar to I equals 0, the initial case, v in I_pairs array value. Array value is a table of a sequence of values 5, 6, 7, 8, and 9. We can use I_pairs to get the value of those as we move through them. So that allows us to move through a sequence of data. This is a very common programming technique used across many different languages when we want to move through a sequence of data, often moving through an array, but in this case in Lua, moving through a table using the function iPairs and the table we want to move through. So we see for I, v, in, iPairs, do. Again, the for, do, end structure. In this case, we're printing v, and in each case, v is equal to the individual numbers 5, 6, 7, 8, and 9, which we see right here in our output. 5, 6, 7, 8, and 9. Moving using iPairs in each loop through this, moving through a sequence of data. In this case, a table as a sequence of data, using the index each time to move through these. Finally, if we don't have a sequence of data, but we have a key value pairs, or in this case an object, we can do the same thing using the pairs function. So instead of using iPairs or integer pairs, we can use pairs. And it's the same structure we just saw using the loop. For, do, end. In this case, for k in pairs, what we want to go through, table value, do, k, which is the key, and then the value using that key. So we see here in the print, Dan equals, or name Dan, age 33, which we see over here, name Dan, age 33. So we can use the function pairs to move through pairs of values within a table, and iPairs when we want to move through integer pairs or sequence of data. So let's review all of this. Starting from the top, we can define objects using curly brackets by setting its own properties, name equals Sam, ID equals 1, 2, 3, 4. And while that can be useful and we can access that using person.name, person.id, it's not terribly helpful if we want to dynamically create things or change values depending on other conditions. For that, we can use setMetaTable. And we see lines 9 through 16 as an example of that. We define an empty table is equal to human in this case. We define a new function as part of that table, human : new. Using setMetaTable, we can define a new table with its meta, its type, to be human. We can then change the self.name to be equal to what we're sending into this function. Self.name is equal to name, self.id is equal to ID. Then we return self, which is the new table with those properties of the type we set it to so that it matches. We saw that on line 18. We created a new variable, Dan equal to human new, send data into this, Dan and 1985, and we were able to print Dan equals name, which is Dan. We also saw when we're using loops that Lua gives us a shortcut to move through these. I equals 0, the maximum we want to move to using the for, do, end structure. Similar to functions, these are tabbed in using whitespace. For, do, end, from I equals 0 to a maximum of 10, do, which we saw this is loop 0 through this is loop 10. We also saw we can move through a sequence of values using the in keyword and the iPairs function or integer pairs function. So we saw this for I, v in iPairs, the table we want to move through, for, do, end. We can also see we can use that as the same structure of key values that we have down here. Name equals Dan, age equals 33 that we saw right here at the top, where we're treating a table as an object using the pairs value, the pairs function, and for k in pairs, the name of the table, do, and we can move through a table with its key and values. Thanks for watching.